Wave sounds can travel through anything: gas, solids, liquids, etc. This means that because gas, solids, and liquids all have a different density, sound waves will always have a different consistency. When traveling through any of these, sound comes from a vibration of an object. This creates a wave. This wave is what causes particles that are from a medium to vibrate along. As they move, they will collide with each other and create sound waves. For example, thunder. Usually you will first see lightning strike and then hear it. How does this work? Well, because sound travels slower than light and air, this means that it will take sound more time to reach us. Because air is made up of gases, this means that particles are farther apart, which causes sound waves to take longer for it to travel. A second example is liquids. Sound is better at traveling through water because water is denser, meaning the water particles are closer together than air particles. When a whale produces sound waves to call for other whales, the sound being made is so much louder underwater than in air. However, it's not only because the sound waves traveling through water that makes the whales call loud, but also because they are loud. The intensity of the sound waves being produced by the whales is also a big factor of these waves. It also depends on the intensity of the sound waves and vibration. A final example is solids. Sound waves are better at traveling through solids compared to gases and liquids. The particles in solids are closer together. This means that sound travels better through this medium. When a metal spoon drops to the floor, as soon as it hits the floor, it creates a loud and fast sound. When playing a piano and pressing down on the keys, it will create what is called natural frequency. This is the sound that the piano was created to make. This is how natural frequency works. However, if the piano gets hit by a hammer, it will create a forced vibration, meaning that its natural frequency was disturbed by an outside force or energy. This is how forced vibrations work. A vibration resonance occurs when equipment or a product is exposed to external force vibration occurring at one or more of its natural frequencies. The resulting product response vibration is amplified and can be huge. Vibration responses can cause severe damage to products and significantly shorten their life. A mathematical example of wave sound is traveling through air. The frequency used to create the sound wave on the resonance tube was 320 Hz. We first needed to calculate the length of the air column, which was 0.22 meters, and the diagram of the tube, which was 0.3 meters. We added those up, and then to correct the length, we added 0.4 diameter of the tube. Corrected length came out to be 0.52 meters. Finally, to find the wavelength, we used the corrected length and multiplied that by 4, which equals to a wavelength of 2.08 meters. Using our wavelength, we divided it by the frequency, which is 320 Hz, and with this we were able to find our speed in the air, which was 153.85 meters per second.